Okay, here's the second, well, no hands video. I'm using hands here, but you're not going to see my hands. Awesome. So this is doing my Raspberry Pi Bramble. So I showed how to install, put them together. They're running here beside me. Next thing you need to do is get an operating system installed onto the SD card. So there was there's many instructions on how to do this. I ended up you can use the Raspberry Pi OS. Problem with the Raspberry Pi OS is that they don't yet have a 64-bit operating system for Raspberry Pi OS. They only have a 32-bit operating system, according to Raspberry Pi, and they have good reason to do that. That limits the amount of memory you have to 4 gigabytes, but mostly it limits you in the architecture of the software that you can run. So if you're going to do Docker, changing to 64-bit will mean that there's fewer applications that you can run in 64-bit. You might think that that's a downside, but actually it's an upside because you want to have 64-bit in order to take advantage of 8 gigabytes of memory. And right now, I don't have 8 gigabytes of memory on these Raspberry Pis, but you're going to run 64-bit in production environments all the time. So defaulting to 64-bit is really important because it gives you, it exposes you to some of the problems that you might have, some of the challenges. It is better. You must do it because of the memory limitation. 32-bit only lets you access 4 gigabytes of memory. Anyway, so I found that the installation for the SD card for how to install Ubuntu on the Raspberry Pi, they didn't work from what other people were saying. There was a tool called Balena/Etcher. It didn't write the Ubuntu image properly, so I ended up using from official Ubuntu how to install their ARM64 architecture for Raspberry Pi. So you basically have to choose Raspberry Pi OS Other and then find Ubuntu Server 64-bit or ARM64, because that's the other important thing about the Raspberry Pi. It's not x86 architecture like the AMD and Intel CPUs that we have on our desks. It's an ARM-based processor, so that is another thing that has a bit of a challenge for running containers on Raspberry Pi because a lot of the Docker images aren't built for ARM64. So there are ways around it, but it's also great learning to work with that. So basically, anyway, I'm not going to go more about that. Another couple of neat things are you can enable Secure Shell by making a file on the boot partition just with a file name of SSH. I already did that. That way you have SSH enabled and you don't have to necessarily connect a display up to it. I'm getting a little bit more into things, but anyway, next step I did was I booted the Raspberry Pi, connected a display so that I could see what the IP was. The other ways you can get the IP from your Raspberry Pi is to look at the DHCP leases on your router for your home network. That's another great way to do it. Lots of different ways, or you can just log in with the with a USB keyboard attached and just look at it. Anyway, that's all great stuff too. I also set a DHCP exception for the MAC address of each of the Pis that I have, so that I know that when DHCP happens, it'll see that MAC address. My router will see that MAC address and assign the same address each time. It's that way you don't get a different address, which you can, not normally, but you can. You'll have to change your password too as well anyway. But I ended up setting my host name because the default is Pi. I called this one Pi2 because it's the second one. I'm not going to show the first one because I can't connect both. Well, I can, but I'm not going to show the first one. You can set the host name with the with the hostname ctl command. Anyway, but I also have to install the ifconfig command. I've already done that. So when you do ifconfig, you can see that the address for this particular one is 1.80. I had to do a sudo apt-get install nettools basically here. When Ubuntu doesn't have a tool, it will usually say that what to run to install it. It's pretty handy that way, so that's kind of nice. The other thing you need to do is update everything. So you need to do a sudo apt-get update. Then you need to do also an apt-get upgrade. Update gets package updates, but it doesn't actually update anything. There's nothing to get here because I've already updated it, but I'm just running it. So like apt-get upgrade will say, what was upgraded and what happened. You may see notes about that certain things are not upgraded and they're still available to. So the last one you need to do is do a apt-get distribution upgrade, and that'll install it and update everything. So that I've already done that, so that's all done here. The other thing you need to do is adjust memory settings to use the k3s or the Kubernetes lightweight Kubernetes that you're going to be running on a Pi, or I'm going to be running on a Pi. The way you do that is I can get out of that. So you look at you edit a certain file, boot firmware command line.txt, and then at the end, this is just one big long line, by the way. It looks like it's wrapped, but you got to be careful because it's just one line of text. It's not two lines. And you need to add this on the end of it, these C group statements. C group enables CPU set and memory and this kind of stuff. So I didn't look too deeply into what the C group and things were, but basically K3s is a requirement where it uses these C groups to do certain things. So anyway, you need to do that. You can also, once you've done that, you have to reboot the Pi. You can test to see if it's on, because if you grep mem from proc C groups, you'll see that 1 means that it's enabled, so that's all fine. I'm not going to go into public key setups. It's pretty, well, public key authentication lets you not use a password to install, to remote into a system for Linux usually. In the .ssh directory, you'll see a bunch of files, idrsa and idrsa.pub. These are the two files. This is the private key, this is the public key. And if you look at the public key and the private key, you can see the private key one says, "Hi, I'm a private key." And the other one says, doesn't actually say that, but anyway, you keep your private key secret, and you can give your public key out because your private key is used. It's the only thing that can authenticate against your public key. So the system's ensured that since you have control of the private key, only you are able to decode things with the public key, so it can use that as a authentication mechanism to let you in without the password. Problem is, it can be a little bit tricky. You do have to make sure that when you're doing this, that the private key needs to match the public key that you're going to be using, and only the public key needs to be copied to the systems that you want to access from this host, for example, or from any host. Maybe it sounds, I don't want to get into it too much because I might start confusing things. I had some problems with the private key myself. I end up using the PuTTY SSH client a lot. It turned out that PuTTY is old, and Ubuntu now is supporting newer key structures. So I had to actually generate and convert a new public-private key pair with PuTTY for use here without, anyway, it added some complexity, but really you can probably avoid all this by using a different SSH client like MOBA Xterm. That's a Windows one that works pretty well. And I found that it's pretty nice. So I probably would recommend against PuTTY, but anyway, your mileage may vary. Anyway, make sure that public private key is working. And an example of this will be I can now SSH Ubuntu user at 192.168.1.79, which is the IP of the Pi 1 that I have. And when it's all set up, it just lets you in. And you can see that I'm in Pi 1. So I can run commands there because I'm remoted in as onto Pi 1 from there. Great. So I've also got those keys on my local machine so that I can use an SSH client to go in, and you will need those for the client portion when you're using k3s tools to access the cluster. You need to have the private and public key from your cluster on your client machine. Anyway, so I use Windows subsystem for Linux. I'm not going to be, once you've got the public key, private key set up and all that stuff, you actually, I'm going to move over to my, well, this is a Linux, Ubuntu Linux running on Windows. It's Windows subsystem for Linux. So I'm using this on my Windows machine as my client to access my cluster. So the next thing you need to do is actually get a couple of tools to let you use this client to interface with the nodes in your cluster. So even, and in a production grade thing too, you're not going to be logging into the nodes or Kubernetes directly. You're going to be using a client, and you can use Windows. I'm using Linux just because it's you'll learn more using Linux, and I prefer, yeah, anyway. So a couple of things you need to do. You need to set up a thing called arcade, which is not arcade for games. Arcade is an old word for like a shopping plaza or a way to, get things. It's an like, or it's also a name for an outdoor courtyard. Anyway, that's that kind of arcade. It's spelled with a K. You need to do a couple of things to get also this k3 sup command. I don't know what it stands for, but it's one of the things that you use to install and get things going on your cluster. I've already installed the arcade and k3 sup. So if I do a, I'm actually, and I've also done the master node in my cluster already. So I'm not going to install the master node again, but there is a command to join. I'm going to join my second Raspberry Pi. Okay. I might, I've edited out some of the stuff in between here. You might see a jump. Anyway, what needs to happen is there's a different command. The join command, you need the IP of the new node that you're going to and the IP of the master that you've already got set up. So it's not just, it was trying to, anyway. So now we can see that it's installed, it's joined this node to my master. And if we can see now we can test it by, should be able to get node by using this get node 0 minus O wide. So you can see there's a Pi 1, that's the master. Pi 2 is available, and there we go. So we got them, we got those things installed. So great. So now, now that we've got the two things in the cluster, I'm going to install something. We're going to install something here to see how it's basically seeing if we can actually add something. So there's a metric server. Let's install a metric server to see some. Actually, no. Let's try the Kubernetes dashboard. Sorry. So we're just going to do we're going to use that arcade app, and it's basically just as simple as arcade install Kubernetes dashboard. You can see the architecture ARM64 has been used. So now that we've got that, we do have to do what we need to do. We got to get a token for this to work. So the token says what you need to do here to get it to forward. We already did that. We don't need to do that. Oh, actually, I guess we need to do all these things. Okay, so we're going to proxy this thing. Okay. So got that going, and then we do. Oh, we need oh, okay. Actually, we need this first. Stop the proxying. Get the token. There's the token. Now we can start the proxy. And now we can use this web link to do that. So let's do that here. Okay. So we're going to pick token. And we're going to go back here and get the token here. Oops. Gotta paste it first. Sign in. Let's see what happens. Hey, look at that. Cool. So we haven't deployed anything with the dashboard yet, so I guess there's nothing here yet. Anyway, okay. So doesn't seem to be anything here yet. Let's well, maybe we'll just end there for today because yeah. Anyway, what we did was we did get something going. We can see that there is stuff, there's nodes available, and we deployed at least one app anyway, but it's not running very well. Anyway, let's stop there. So the more things will be getting various containers set up and things like that later. So yeah, thanks. It was a bit longer than I thought.